Okay, everybody, let's tackle statistical significance. And to do that, let's actually start with normal distribution. So this is an example of a normal distribution. We can see that most people score here in the middle. So on this side is number of people, number of scores, and this is how well people did on the test. And the intelligence test is actually a nice example for normal distribution because that's how it's defined. So people who are average intelligence are labeled as having a score of 100. And we'll see that most people have a score of 100. A standard deviation is a standard set amount of deviation, movement from the mean. So one standard deviation out on intelligence tests is defined as 15 points. It's the point at which 34% of the population falls above the mean and 34% falls below the mean. So this is one standard deviation below the mean, and this is one standard deviation above the mean. So that means that 68% of the population score between an 85 and 115 on intelligence tests. If we go out another standard deviation, if we go 2 standard deviations to the right, people who score up to 130 are going to be 2 standard deviations out, and people who score between 70 and 85 are going to be 2 standard deviations out. So that means a total of 95% of the population falls between scores of 70 on the intelligence test and 130. So between 2 standard deviations. And then 3 standard deviations, we go even lower. People who score 55, between 55 and 70 make up about 2% of the population. People who score between 130 and 145 also make up about 2% of the population. And so this is 1 standard deviation from the mean, 2 standard deviations from the mean, and that is 3 standard deviations. And then 0.1% of the population score above 145, and 0.1% of the population score below 55. Alright, so whenever we're talking about a normal curve, this is what we're talking about. Most people score here in the middle. 68% score between 1 standard deviation below, 1 standard deviation above. 95% score between 2 standard deviations below, 2 standard deviations above. Over 99% score between 3 standard deviations below and 3 standard deviations above, and then the remainder are out in, the tiny remainder are out in these tails. So that's a normal distribution. So let's take an example. This is from an experiment that you have for your research methods 2. Your author talks about this in one of the chapters. So in this experiment, if you want, you can click on this link and you can go and read about the experiment yourself. This particular example was taken from the 3rd study discussed in that paper. So what they did is they had people, 2 different groups of people randomly divided into 2. One group was asked to grade a paper with a red pen. The other group was asked to do the same thing with a blue pen. And then they were asked, what grade do you give on this paper? And what they found is that when people were grading with a red pen, they gave it an average score of 76.2, and when they were grading with a blue pen, they gave it an average score of 80. Now the red pen standard deviation, 12.3. So that means that the mean was 76.2, and then 1 standard deviation in this direction is add 12.3, 1 standard deviation in the other direction, subtract 12.3. If you want to go out 2 standard deviations in this direction, add another 12.3. In this direction, subtract another 12.3. For the blue pen, it was a smaller standard deviation, 9.4. That means that the scores were more compact. So the mean of 80 one standard deviation out, 9.4. One standard deviation in the other direction, subtract 9.4. So 68% of the people scored between, roughly 70 and 90. So let's see what this looks like. Now, of course, the big question for us in doing an experiment like this is, okay, so we know that the red pen mean is 76.2, blue pen mean, that's 80. Is that really a difference? How do we know? Like, could it just happen by chance that the red pen people gave an average score of 76? You know, if it was a 79 and an 80, yeah, that was probably just due by chance. But 76.2 and 80, is that due to chance? Well, let's take a look at what the normal curves look like for these. So for the blue pen, this would be 80, a score of 80, and one standard deviation, ignore these lines, but about one standard deviation out is going to be 9.4, one standard deviation in the other direction, subtract 9.4, and we get about 68%. Not about, we get 68% falling in between those two standard deviations. For the red pen, the mean was 76.2, so it's lower. And the standard deviation, though, is bigger. So the scores are more spread out. As you can see, that's why this normal curve is wider than the blue one is. So, fortunately, there's a formula that we use. There are actually several statistical formulas that researchers use, depending on the kind of data that they have, to figure out if there is a statistical significance. They don't have to look at charts like this. But when we look at this, we can see that we get a good chunk of people here who didn't score. If we draw a line right here, an imaginary line here, then all of these people scored where none of the red people did. And if we go in this direction, we have a lot of red people who are scoring below what the blue people did. So what our statistical test shows us, not this, but a fancy formula, what it shows is that, yeah, it's really unlikely that this would happen by chance. And so we would say that these results are statistically significant. Now, real world significance, that's a whole other question. You know, if this were, something like, fancy schmancy drug, and it relieves pain in 80% of people who take it, and this is a placebo, and it relieves pain in 76% of people who take it. Well, statistically, yeah, the results are significant, but out there in the real world, does that really make a difference? How important is that? Is that fancy schmancy drug worth that 3% more? I mean, if the placebo, essentially a sugar pill, is going to be that effective, it probably isn't worth putting all the time and energy and money into developing and selling that fancy schmancy drug. Now, here are the results that these researchers did not get, but would have thought would have been extra awesome. So imagine that the red pen mean was 70 with a standard deviation of 5. The blue pen mean was 80 with a standard deviation of 5. And so that's what these normal curves would then look like. And we can see, yeah, there's some overlap, that there are plenty of blue people and red people who scored the same on the test. But boy, when there was a blue pen, remember, these data are completely fictional. But if it had been, all of these people scored way higher than all of these people. We would be really, really confident in the results. There'd be no question about statistical significance. Unfortunately, that isn't the results they got. They got these where it's a little harder to see. But the statistical formula does say, yeah, there's enough of a difference here to say, yeah, it's statistically significant. So, does that help? If not, drop me an email.